Good morning, class. Today we are going to be working on the mole and SI units. As you can see in front of me, what I have here is the guided notes we're going to be following along with today on October 13th and 14th as we go through what a mole is, who discovered it, this guy right here, Amedeo Avogadro, we'll talk about him soon, and the SI units. We're going to be going over those as well so we get a firm grasp on everything we're going to need to know for this year. So to do that, I want to first start out with today, the catalyst for today. Balance the following chemical reactions. Excuse me, I left some of the answers in there. So here are the reactions you guys are supposed to balance. Once again, if you have any problems with it, try and look at the number of elements on each side. Give it a shot before you answer each one. Each side of the arrow is going to attempt to have the same number. So you guys have about 3 minutes to go for that one. Once you're done, how many M&Ms do you think we can fit in this classroom? So that's what you guys need for today. I'll give you about 3 minutes to do this. You can pause it now. Take about 3 minutes. Ready? Go. Okay, now we've about finished that section of the catalyst for the day. That was done on your daily work organizer. Today we're going to be working on a lab involving M&Ms and the mole. So what does the mole look like? Let's talk about the mole. Whoa! That's a mole. This little furry creature right here lives on the ground, hunts bugs, excuse me, and other creatures. It's a little furry rodent. It is a mole. M-O-L-E. That's true. Ooh, this thing right there. Yeah, that's also a mole. On your face, sometimes hairy, not that good looking. Those are also moles. M-O-L-E in the same way. Last but not least, oh, boom! Wow, that's a big number. That is also a mole. Now, who tells you that's a mole? This guy right here, Amedeo Avogadro. Now, Amedeo Avogadro, not necessarily the best looking individual, but a very smart Italian chemist. So let's talk about what he's done. And as I go through these lecture notes, I would like you guys to follow along on your guided notes about the mole. So you're going to fill in your answers in these blanks, like the blank I just highlighted. So over here, I maybe put understand. So I want you to go ahead and take notes as I go through this lecture. So let's begin. Today's objectives. Students will be able to explain the concept of the mole that is defined as 6.022 times 10 to the 23rd particles, and that the size of one mole varies depending on the molecule. Students will be able to explain why 1 mole of C12 is equal to 12 grams of C12, and discuss the SI system of measurement, and defend why scientists use this to measure. So you can go ahead and pause and write those in. Once you're done, you can play the video again. The mole is contained within any substance we can see. It is trillions on trillions of atoms. We need a simpler way of conveying the amount of atoms that are contained in any substance. So the mole is a unit that explains how much something is. So just like a dozen means 12, if we go buy a dozen donuts, how many are we buying? 12 donuts. If you go buy a mole of donuts, you're buying 6.022 times 10 to the 23rd donuts. Someone in the donut shop is going to be very excited if you order that many donuts. This is how big it is. Woo! That is a big old number. Right there. How high can you count? You can never count that high. So let's talk about it. Today we're going to work on a lab. So you're going to read through the lab handout about the mole and work in groups of 4. That's 4, not 3. Not 2, not 5, not by yourself, but 4. And you're going to answer the questions once you've read through the entire handout. You have about 30 minutes to finish. The handout, which I'll go over with you right now, looks like this. We have a mole over here, writing a mole on the board. So, it is a rather large number. Most of us have little idea how large this number actually is. Despite this number being hard to understand, the mole is one of the most common units of measurable chemistry. So you're going to need M&M candies, ruler, calculator is what you use on your computers, and a cubic decimeter. I have a cubic decimeter in a little pink cube on my desk. So what you're going to do is you're going to fill that cube with M&Ms. Once you've filled it up, you're going to count the number of M&Ms in one cube and record this on your data table down here. Then, with the ruler you picked up, measure the length, width, and height of the classroom in centimeters. Record this in the data table. So you would record that right here in centimeters. Remember, we're doing it in centimeters, and on a ruler, there are 30 centimeters for every one ruler. So count the number of rulers, multiply it by 30. You're going to convert that length, width, and height of the classroom into meters by taking the number of centimeters you measured and multiplying it by 1 over 100. That's the same thing as dividing it by 100. So you'll calculate the volume of the classroom by multiplying the length, width, and height by one another, and record it in the data table. So once you've turned it into meters, divided all of these numbers by 100, you're going to multiply this one, and this one together to get this answer right here. That will be the volume of the classroom. Then, what you would do is you would take the number of M&Ms you recorded, the total number of M&Ms in the pink cube. You're going to multiply that by 2. And that's going to be your number for right here, for the first part of this equation. Then, you're going to take that number, multiply it by 1,000 decimeters in 1 meter. And that is your answer for number of M&Ms in 1 meter cubed. To find out how many M&Ms fit in the classroom, you take number of M&Ms in 1 meter cubed times the number of meters cubed in a classroom. That is going to give you a number of M&Ms in a classroom. So you're going to take this number that you got right here, which is the same answer as this right here, and you're going to multiply it by the volume of the classroom. So total number of M&Ms in 1 decimeter times 1,000 multiplied by the volume of the classroom. You're going to get the number of M&Ms in 1 classroom. Once you've done that, take the number of M&Ms in 1 classroom and divide it by 6.02 times 10 to the 23rd. That will give you how many moles 1 classroom of M&Ms equals. It's going to be a very, very small number. Very small. I promise you. The next thing you're going to do is you're going to take the number of M&Ms that fit in 1 classroom right here and flip it. So it's 1 over that number. So you're going to take a 1 divided by your answer for here times 6.02 times 10 to the 23rd. That is going to give you a very large number, the number of classrooms needed to hold 1 mole of M&Ms. And then you're going to answer these 3 questions. You guys have about 30 minutes. Good luck. Have fun. Enjoy the M&Ms once you're done.